Very good evening friends, and in this video we are going to solve the remaining questions of exercise 9.5 CBSE board and CERT textbook. Here I have copied down all these questions, and now there are how many questions? I think there are around 17-18 questions are there. All these questions are based on the idea of the homogeneous equations. In the previous video we solved 2-3 questions and then we discussed the idea of the homogeneity. How can you establish the homogeneity? How can you find the degree of homogeneous function of two variable, of course. So now we are continuing solving this question. Now this is challenge series where I will be solving these questions as fast as I can. So just here I go. So this is question number 2. Question number 2 says find, this is you are given as y dash as x plus y over x. Now just see that if you replace x by kx and y by ky and x by kx, you will find kx plus ky over kx. K taking common from the numerator becomes x plus y over kx. Then k and k cancels, is x plus y. So this function f kx ky is k to the power 0 fxy, means this is a homogeneous function of degree 0. Most of the questions are definitely homogeneous because it has to deal. Now otherwise also we discussed that if we take y to the power something common, and if the function is represented in terms of x over y, and then later we can write x by y as something like v or y by x as v, depending on whether the function is of the form, the function is the function of x by y or y by x. So in this condition I simply divide this. So here write x over x is 1 plus y over x is y by x, and this is dy over dx. Now you see we are getting y by x. This part right now is not, this explanation is done. So here we have 1 dy by dx is 1 plus y. Okay, let me write properly. This is 1 plus y over x. What we do, that we'll write y over x as v. So y is vx, and then dy over dx is v plus x dv over dx. So this question becomes v plus x dv over dx, and that is 1 plus v. V and v cancel. We have x dv over dx as 1. Then we break this down using the idea of separation of variables. So this becomes dx over x on the right hand side and the dv just on the left hand side. Now I integrate. Now see, if you cross multiply, find dx is x dv, dx is x dv, same. So now on integrations dv is 1 is hidden there, so integration is v, and this is log x plus, I can write the constant, like the constant of integration also as log c. So here I get v is log cx. Therefore what is v? V is y over x. So now I replace this v and write y by x. Then I can write cx is e to the power y by x. This can be a possible form. When you represent the answer in the final form may be a little different from what the form is given behind the textbook, because algebraical expressions with the exponential terms or the logarithmic terms or the having trigonometric functions can be expressed in some other forms also. This you have already studied in the previous your standard, and that's why our answer can be a little different, but they are not wrong. So this question is done. Now I go for the question number 3. So let me remove all this, and there it is, question number 3. It's x minus y dy minus x plus y dx is 0. So first I'll write dy over dx. So what I do that, I take this on this side, and instead of saving my energy, I remove this equal, and here this becomes equal. So then I write dy over dx as x plus y over x minus y. Now if you write x as kx and the y is ky, and this also x is kx and ky, I'll find that k you can take common from the numerator as well as from denominator. These two k's will cancel each other, so this is a homogeneous function of degree 0. Now how to convert this in the form of y over x, just like the previous question? So you just divide this whole fractions, numerator and denominator, both by x. So as a result, this will become 1 plus y over x, and this becomes 1 minus y over x. This is dy by dx. Now you must be accustomed to this idea that the y over x is v, and then y should be written as xv, where dy by dx is x v plus x dv by dx. This part is going to be common as long as you are substituting y over x as v, or you have been able to express the functions fxy as the functions of y over x. So here I write this one is v plus x dv over dx. This is 1 plus v over 1 minus v. Now x dv over dx as 1 plus v over 1 minus v, and this one gives the answer like x dv over dx as 1 plus v minus 1 plus v over 1 minus v is 1 plus v minus v plus v square over 1 minus v. So v cancel, this is 1 plus v square over 1 minus v, and this is x dv by dx. Now I have to use the method of separation of variables, keeping the function of v's together with dv. So here I get 1 minus v over 1 plus v square dv as dx over x. Now if I integrate here these two, then I find two equations are there. One is 1 over 1 plus v square dv, minus another one is v over 1 plus v square dv, and that is integration of dx over x. Now at the place of, since if you write 1 plus v square as t, you find 2v dv as 2v dv as dt. So here 2v is missing, so I write here 1 over 2 there, and then I write 2. So it means if you take 1 plus v square as something, 2v dv will be its differential. It means this is going in the form of log of 1 plus something. Then, and this one is, you see that it is tan inverse v. So here we have tan inverse v minus 1 by 2 log mod 1 plus v square is log mod x. So there are already two log terms, so I will introduce the constant also as log x. So this is our final, not final answer, because I have to substitute v as y by x. So I need space, so let me get rid of this part. Okay, so here we have tan inverse v. We can write this as tan inverse, what is v? Y over x, minus 1 by 2 log 1 plus v square. You see, 1 plus v square is 1 plus y square over x square, and that is x square plus y square over x square. So here we write x square plus y square over x square. This is log x is log x plus log c. Okay, now okay, leave it there. So I write again the answer as tan inverse y over x minus 1 by 2. This is log m, and log m upon n. Log m upon n can be written as log mn. So here I do that. If I take this on this side, this on this side, so both of them will become negative. Okay, and this is negative, this is also negative, so finally they will add up together. So what you can find, let me get rid of this part also because I need better space. So this one I can write as half log x square plus y square. This is minus, and this is going to give you form log m over n is log m minus log n, which is already negative, so it will become plus half, and then I'll get log x square, but the log x square is nothing but 2 log x, so there it is, 2 log x equals log x plus c. Now you see this 2 to cancel, this log x will cancel by this log x, so you have this answer. I have taken this as log c, or you can write c, well, but whatever way is possible you can write. So I am getting my answer is y inverse x over y by x minus half log x square plus y square is c. So log c constant, whether it's you write sin c, cos c, e to the power c, is just constant. Constant is just a number which does not change. So c you can write anything, whatever you feel like. So this is my answer. This can be simplified a little more further, but I don't want to do it. This is my final answer. Now I go for question number 4, but let me get rid of this part of screen. So here the screen is clear, and question number 4. So the question number 4, friends, goes that finds, questions are not very difficult, they are easy, but I am just challenging myself how fast and how long I can solve these questions. X square minus y square dx plus 2xy dy as 0. So what I write that, I write simply directly dy over dx. So dy over dx, then minus sign, and then whatever is with dy that will go down, that is 2xy, and whatever is with dx, that is x square minus y square, it goes here. Now if you see, just by visual inspection of this proper form, you will find this is a homogeneous function of degree 0. Now this minus I don't like, so I can remove this minus sign, and this will be compensated here, and this x square minus y square will become y square minus x square, that is y square minus x square over 2xy dy over dx. Now our final task is to express this function, the function of x over y or y over x. So here I say that if I directly divide the y square over 2x, what I do that I divide both numerator and denominator by x square. So divide up and down by x square. This becomes y square by x square minus 1, and here you see that this becomes 2y by x. So this dy by dx, I am not writing that y upon x as v because it's already I have memorized it. So I write at the place of this dy by dx, I write v plus x dv by dx, and this is v square minus 1 over 2v. Got it? Now I take this 2v on this side, and I am removing this because I want it clean. At least you understand. So be little smarter, think little wiser, and this is how the one man is different from another man just by degree of concentration. What is keeping one man away from another man? So v plus x dv by dx, this is v square minus 1, v square, this looks a little nasty, v square minus 1 over 2v, and this is minus v. I don't need this v here. So now it is x dv over dx, that is, if you simplify, you'll find v square minus 1 minus 2v square over 2v. So this is x dv over dx is minus 1 minus v square over 2v. Then I keep this 2v here, 2v upon, I can keep this minus there, and there I write 1 plus v square dv, and this dx goes here over x down, and I integrate like this. You can check it out, this is perfect, but I am doing it faster because I can do it faster. Yes. So now again, if you take 1 plus v square, these are the final chapters. After doing so many chapters on integrations and differentiations, I think you must also be in position to do the things a little faster, right? So this 1 plus v square, if you take it as t, you get 2v dv as dt. So this is just directly log mod 1 plus v square. This is minus log mod x. Here I'll prefer log c. So now this is log 1 plus v square. You have already seen this always comes as 1 plus y square over x square, that is x square plus y square over x square. So this gives you log x square plus y square over x square, plus I take this log x on this side, log x is log c. Now log m plus log n is log mn, and if you multiply the argument of these two log functions, then you see it's x goes on numerator and this one cancelled. So I simply make it this as x and this is gone. At least this kind of understanding you all should have. So now if I take the anti-log on both sides, what I get, that x square plus y square over x is c, and that I write as xc, and this is my answer. Now I go for the next question. Question number 5, which I have already solved. So I'll go directly for question number 6. Now let me get my screen clear. Yes. So question number 4. Question number 5 we have done. I think, oh no, question number 5 we haven't done. We have done question number 6 in the last video. So I solve question number 5 again. This is x square dy by dx. Now my confidence is building up so as yours. So I'll be a little more faster and try to be quicker with skipping some of the unimportant steps, because a smart person doesn't take long to solve a question. Now I write this as x square is gone from here, then you find dy over dx as x square minus 2y square plus xy over x square. Now just divide x square over x square is 1 minus 2 y square over x square plus xy over x square. X cancels, just y over x, and this is dy by dx. Again continue from where you left in last question, that is y over x as v, and then y you are getting as vx, and then dy over dx as v plus x dv over dx. Now at the place of dy I'll write the v plus x dv by dx, that is 1 minus 2v square plus v. Now this v and this v cancel, then we get dv over 1 minus 2v square is dx over x, and this is integration on both sides. Now here you see that this part is just coming in the form of 1 over a square minus x square, but you have to take this 2 common. So what I get, that I take this 2 common, so from the denominators comes here 1 over 2, and then at the place of dv, then this one, this is here, now becomes 1 over 2. I can write it as 1 over root 2 whole square minus v square, and that is equals integration of dx over x. Now this is the form of 1 over a square minus v square, a square minus x square, and it is 1 over 2a log mod a plus x over a minus x. So I use that property, 1 over 2 dot 1 over 2a, that is 1 over, this is 2a log mod a plus x, that is 1 over root 2 plus v over 1 over root 2 minus v, that is log mod x plus log c. Now this 2 becomes 4, and this 2 goes up, this becomes 1 by 2 root 2. Now we can write this as root 2 by 4. That is fine, because we have been asked not to write this irrational source denominator in the denominator. So you can take it as I have simply rationalized it, and now at the place of v we need to write y by x. So what this will become, log mod 1 by root 2, 1 by root 2 plus y by x. This will become x plus root 2y upon x, and this becomes x minus root 2y upon x. This upon x from both sides cancel each other, and this is log mod xc. Now you can take anti-log if you feel like doing so, or even if you leave the answer here, that is also no problem. So if I take the anti-log, what I get, this one will be a problem, because first I have to get rid of this one, and this is in the form of n log m, that this one goes to the power. So I leave my answer here only because I think this is a better form. Now I go for question number 7, because question number 6 I have already solved in the previous video. So now I remove this part of screen. So here it goes, and see question number 5. Then I go to the question number 7. Again I'm saying question number 6 I have solved in the previous video, and this is question number 7. Question number 7 goes like, how to find the solves differential equation, which goes like this: x cos y over x plus y sine y over x. So this, you see, is kind of the function of y over x, good for us because it is already there, y, and then dx equals again braces, and this is y sine y over x minus x cos y over x dy. So what do we need to have? We need to have dy by dx. So this is dy is here and dx is here, and this is why we need to have dy by dx, because this is always mandatory. And even if you want to write dx by dy, there is no problem there, but you should follow the standard, so that's why it will have the less confusion. Now when I do that, I get rid of this x and put it there. So this x is gone from here and this comes here. Fine. Then I take this dx down there, so I write this dy by dx equals, I take this whole thing below. So what this become? Pay attention. X cos y by x plus y sine y over x, and this is y by x. So y by x upon the same thing in the curly braces again. This is y sine y over x minus x cos y over x, and this is your dy over dx. Now this is a homogeneous function of degree 0, because you see that from here is y by x, so kx by kx, kk cancel, here everywhere is cancel. Now we have this x thing here inside. It means we need to divide the numerator and denominator again by x. Why? Because we have to express this in the form of x. So if you divide numerator and denominator by x, then this x is gone from here, and this will become y by x. Same way, this x is gone from here, and this will become y by x. Now this is perfect. So we have to write y equal vx, or at the place of dy by dx we have to write v plus x dv by dx. So this question becomes cos v plus v sin v over v sin v minus cos v. And what is this? This is also v equals, what you'll get? V plus x dv by dx. This is the beautiful part. Now if you take this v on this side, this becomes negative. So I do here. So this becomes x dv by dx, and here it goes, because v is with the numerator, so I just better write like v cos v plus v square sine v over v sine v minus cos v, and this is minus v. So now take the LCM and this will become v cos v plus v square sine v minus v square sine v plus v cos v over v sine v minus cos v, and that is equal x dv by dx. Now v square cancel and these two v's are adding up. So I remove this part of screen, this part is done. So here and there we have 2v cos v, 2v cos v, v cos v plus v cos v is 2v cos v over v sin v minus cos v, v sin v minus cos v equals x dv by dx. Now you see what we need, that we have to use the method of separation of variable. I take this dx here, x down, so dx over x, this one goes up, so v sin v minus cos v over 2v cos v, okay, and we have to integrate these two. Now the question is that how will you solve this? So the answer is that this part is quite integrable, fine. Now the problem is here with this part. So just see that if I assume, let v cos v as t, okay, I'm supposing method of substitution, I'm using v cos v as t. Now differentiate. So v differentiated with respect to v becomes 1, so we get cos v, and then when you differentiate cos v, you'll get minus v sin v, dv is dt. Now just see, yes, that's good part, that if you take minus common, you get v sin v minus cos v, yes, so minus v sin v minus cos v dv is dt. Now I get rid of this minus sign and place it here, so this is gone from here, this is minus. So now what you see, that if I take the denominator as t, we are getting our v sin v minus cos v dv as minus dt, means this one plus this two we have to keep it outside. So let me remove this part of screen. Okay, so what do you get, that this goes something like this, dx over x, and that is 1 by 2 outside, then you write minus dt over t, minus I write here dt over t. Now job is done. So this is log mod x, and that is minus half log mod t plus log c. So now if I get rid of this half, this will become, half will go here, it's minus also, so this becomes log 1 over root t plus log c, so I bring this c here also. Log m plus log n is log mn, and this is my log mod x. Now if I take anti-log, then what I get, x is c root t, okay. Now pay attention to this, therefore x is c, what is t? T is this part, what is in this t? We have got v, and what is v? That is y over x. So c times y by x cos y by x. This is the answer what I am getting, c root t. So this all should be inside the root, and I think I am right. And if you find I have made certain mistakes, then you are always welcome to point it out in the comment section. Now I go to the next question. Then the next question is question number 8, which is the very simple question, and actually all these questions are simple only. These question number 8, I feel like solving faster, but then my mind says that I need to explain them because I am not solving for myself, I am solving for others. So this is x dy over dx minus y plus x sine y by x. Okay, now I divide both sides by x because I want to get y by x. So this x is gone, so this becomes just dy by dx. Dy by dx, this is y by x plus this x is gone, and this is sine y by x is 0. Now again the same pattern, y over x as v. So and this becomes, you have seen it, I am getting bored by writing this is v plus x dv by dx. I am just writing the final statement, it's not that every time I need to derive it. So this one, so dv by dx minus, we have to place of dy by dx, oh sorry, this should be dy by dx. At the place of dy by dx is again not clear as I want to write faster. Someone is dragging me down. Then dy by dx, this is v plus x dv by dx minus v plus sine v is 0. V and v cancel, and then we have x dv by dx is minus sine v. So I take this dx here, dx over x integration, and I keep minus here only, and there I get 1 upon sine down because I am getting dv upon sine v, so it will become cosec v dv. Now what is the integration of cosec v dv? That is log mod cosec v plus cot v, and this is minus log mod x, and there I should have log constant. So this log m minus log n, which becomes log c over x, and this is also log, so I cancel all these log, and then I get cosec v plus cot v, this is log. Okay, right now if I take the anti-log, then these two logs will cancel, so I just save my time and I remove logs from both sides, and then I replace v as y by x. So what you get, cosec y by x plus cot y by x in mod, and that is c over x, so cross multiply x times this is the answer. Okay, thank you very much. Now we'll solve the remaining questions because this video is becoming unnecessarily longer. Thank you very much. Have a very nice time.